Our first example of a logarithmic word problem is a pH word problem. We're going to start off by reading the word problem. Determine the pH of a solution that is 2,300 times the hydrogen ion concentration, or H+, of a solution that has a pH of 4.9. And is this solution an acid or a base? Looking at our problem, we always want to recall our pH formula. pH is equal to the negative log of H+. And in this problem, we aren't only dealing with one solution. We have two solutions that we want to use, but we're going to look at the second part that's given to us of a solution that has a pH of 4.9. So we're going to need to find out the H+ concentration of that solution first. So plugging in, the only thing that we know for our second solution is the pH is equal to 4.9. So we plug that into our basic formula. And then we solve for the H+. So we're going to divide by the negative, and then we're going to get negative 4.9 is equal to the log of H+. And then we take the log, or take the base of 10 on both sides. And when we do the base 10 to the negative 4.9, we get our H+, which is 0.0000126. And now that we have this, we can first we can get the H+. That's what we need to do first. So we times this number by 2,300, and then we can plug it into a new formula to find the pH of this solution, which is what we want, or one of our answers. So plugging it in, pH is equal to the negative log of 0.02898. Then solving, take the negative, or this time we actually just plug straight into our calculator because we don't need to transfer anything. So doing so, we'll get that the pH is equal to 1.538, which means this is an acidic, because anything that is less than 7 is acidic. And that's it. And then for our second logarithmic word problem, we have a sound problem. Our sound problem word problem is: how many times more intense is a sound that is measured at 63 decibels than a sound that is measured at 54 decibels? So again, we're working with two different solutions, or in this sense, different sounds. So we're going to want to compare them. So we can plug them both into a intensity formula. So 63 is equal to 10 log I, because that's our decibel or sound formula to find the intensity. And then what we want to do is first we can divide by this 10. This is using the faster way to solve these problems, which is somewhat better once you get a good understanding. So first we can use this 10 and divide it 63 by 10, and then we'll be left with log I. And then we'll take everything to the base of 10, which will give us on this side 10 to the 63 divided by 10, which will give us 1995262.315 is the intensity of our first sound. And then our second sound, we're going to do the same. We're doing 54 is equal to the 10 times the log of I. So again, divide by 10, and then 10 to the 54 divided by 10 will give us 251188.643. And to compare the decimals, we want to divide both of our intensity ratings, or intensity levels, and we get 79.433 is how many times more intense the 63 decibels is than the 54 decibels. And that's it for both.